Alright, CNT140, we're looking at Chapter 9 on testing our wiring that we have installed. So we're going to get familiar with different tests and testing that we can do for troubleshooting our cabling is what it amounts to. First thing they talk about is coax cabling. Alright, we'll mention it real briefly. If you're installing video cabling, coax cabling for any reason, after it's tested or actually it's installed, you obviously need to test it. They give us two options here. They tell us we can test with a multimeter. Absolutely. If I use a multimeter, I can test the center conductor from end to end, if you will, and then I can test the insulation or the shielding end to end and make sure there's no shorts or anything of those nature. The other thing we can do is there's actually meters, kind of like the wiremap meter that we were used to using in our lab, as well as our continuity meter. There's an adapter here for testing coax. We can use that to test our coax, so we can see if it is functioning. There's any breaks in the shielding, any breaks in the conductor for proper function. All right. The majority of our chapter now is going to be spent on testing our unshielded twisted pair. And they remind us about a couple different tests here, wire mapping, toner wands, that sort of thing. Well, I'm going to break these out and go very deliberately through the different testers and everything that we have. So let's remind us of a couple things we know, and then we'll dig into the different testers and the different things we're looking for, the different problems we're looking for. First thing we need to remember is our wiring structure that we're used to. This right here, our horizontal cabling structure. This is, closet, patch panel, horizontal cable out to outlet, patch cable into workstation. All this is wired straight through. So we need to remember this is all wired straight through. And then if I and actually, here's my color codes. We've been learning the 568A and 568B color code. Here's our 568A and B color codes for our outlets, okay? As we hook up a continuity meter, this is our little continuity meter here. Remember, it's continuity because there's a little battery in here. This sends an electrical charge down one wire. This end of the meter loops it back and back to here, and if we get a complete path on, like the orange pair, if you will, we get a little light here. And the same thing with the green, the blue, and the brown. These light up, giving me a normal straight-through wired cable. That's what our continuity meter is looking for, 9 times out of 10, if you will. So that's what it's testing for. That is normal straight-through wiring, and this is the results I get on my meter. The little wire mapping meter that we have used, this little guy that we have in our lab, again, when it tests, we plug one end of the cable run here, and we use a little remote on the other end. Oh, I didn't put it here. I put the little remote on the other end. It tests the cable run, and I should see a straight-through wire map, just like this, 1 to 1, 2 to 2, because again, our cabling structure is this right here, a straight-through wired network. That is all normal for continuity. That is all normal for wire map or straight through. That's what we're used to. That's what's normal. Okay, so now as we start testing cabling and we encounter faults, we're going to start understanding the faults and how to repair them. The first thing we need to recognize is there's two different types of meters we can use for finding faults. If we have a basic cable function meter and a performance-based meter. Our basic cable function meter are the ones we've been using, the continuity tester and our wire mapper. These do basic tests on the cable run. They're testing for continuity, they're testing for what wire is connected to what pin, if you will. But it really doesn't test much more than that. Nothing about the performance of the cable, the bandwidth of the cable, the crosstalk of the cable, the impedance of the cable, none of that. This is all just basic connectivity. Well, the nice part is these meters are going to catch, 9 out of 10 problems that you encounter on a cable run. It's only when we get to the more specific problems or the performance problems that we need a performance testing meter or a cable certification meter. This guy right here or this guy right here. These are designed to test for cable performance, things like your split pairs, impedance, near and crosstalk length, attenuation, things that would affect the performance of my link. Okay, so my two main categories, basic cable and performance. Again, my basic cable continuity wire map is going to catch most of my problems. It's only when I get into performance things do I need these guys here, certification meters. And just to give you an idea, the continuity meter might be $100, wire mapper might be a couple hundred, maybe $400 or $500 so, if you will. These guys here are usually in the $5,000 to $10,000 category, depending on the features that you have with them. So significant price difference, and I always like to say, more times than not, you won't have one of these in your hands and or in your truck. There might be one back at the shop or one at the other job site. That's why we're going to lean on these a lot for finding our problems first. Okay, the next thing they mention is about wire maps. Yes, we're going to go through wire maps and start understanding what's going on, but a wire map shows up on my wire mapping meter, and the wire map is trying to give me an idea of what particular problem we have on our cable run. Alright, so let's start going through the common cable problems that we would have, and after we understand the problem we have, then we'll talk about how do we fix it. One of the first ones we would have would be a cable wire break, if you will, a wire break. This is normally reported as an open on our tester because there's no circuit, or there's no complete circuit, so there's no path for the current to flow. And they'll say that the actual entire pair might be bad. Okay. Is it always broken? Not necessarily. It could just be poorly terminated. So it might not be terminated well on my outlet jack. That's something that we would need to find out. So if I hook up, again, here's my normal straight through wire map. If I hook up my meter and I get something like this, that it's showing the orange pair is not connected, I would know I need to be checking the terminations on each end of my white-orange wire pair. You know, the outlet jack and the patch panel kind of thing, or both ends of my patch cable. My continuity meter would be showing something like this. It'll show a fail. When I go through my fault check, I'll start showing a particular wire pair is open. And again, that's a clue to be checking, in this case, the white-blue wire pair to see what particular issue I might be having. And again, here's my wire map for my open, and here's my wire mapping meter trying to show me that. And here's actually the one we have in the lab showing you, in this case, pin 4 or wire 4 is not connected. So I would check a little bit closer to find out what's going on. So for repairing this guy, if I only have one wire open, I might be able to look at my terminations, my connections, look at the patch panel, look at the outlet jack, and find out which one might be poorly terminated, and I might be able to just simply re-terminate that end. Okay, so I give you some things here about possibilities of what might be going on. It might just be a bad termination. So for repairing this guy, I tell you here, do your visual inspection, try to find it, use the wire mapper to narrow down maybe which wire. And then for repairing this, if it's at the end, that's easy peasy, I might be able to just re-terminate that end, re-terminate that outlet, re-terminate that patch panel. If I find out that there's a break in the middle of the cable, maybe somebody was doing work and the cable got cut in the middle somehow, unfortunately I'm going to have to replace my cable run. I don't have any other choice here. Okay, I'll have to replace my cable run to do this. Next common problem that we would have would be a wire short. I've actually had this a couple different times as I was terminating things. This can be caused by wires being pinched when they're being terminated, or this is where I have done it. I've cut the insulation off my cable a little too aggressively, and I get a little micro cut in the the white-orange, orange wire kind of thing. And when those two wires lay next to each other in a outlet, they tend to short out. I have had that happen. So if I get a short, what am I going to do? Well, I should say if I'm going to try to find it, if I put it on my meter, what I'm going to find is things like this. Here's my normal wire map. I throw my wire mapping meter on. It usually shows me some kind of connection between the wires or wire pairs that should not be there. So my continuity tester, as I hook it up, again, will show fail. I go through the fault checks. It's going to give me an idea of, in this case, the pair 1, 2 has a short in. So I would need to check, in this case, the orange pair on both ends of my cable run and find out what's doing it. If I throw it on my wire mapping meter, in this case, it's showing me the 4, 5 wires are shorted. Again, I would need to find out which end of the termination is causing this. So for repairing this, again, once I find the bad pair by a bad end, I should be able to just re-terminate. And more times than not, the bad end, if I re-terminate that, I should be in good shape. That's all I usually need to do. Now, actually, let me finish that right here. That's what my standard is going to call for. I will If it's at the end, I can re-terminate. If it's in the middle somewhere, I'm going to need to replace the cable run. Okay. Again, I'll say it. If it's at the end, one of my bad terminations, re-terminate the end. Awesome. If it's in the middle of the cable run, I'm going to need to replace. Now, this is a little emergency side tip. This is not something that'll show up on a quiz or a test. This is just something for your benefit. In an emergency, if you have a short or a cut in the middle of a cable run, what you can often do is you can, if you can locate that cut the wire there and cut that bad section out. And if you have a little slack, you can actually put in a temporary connection where you do a plug in the jack, RJ45 and an outlet, and plug those two together to make you a temporary connection. And I always remind you, this is not something you're going to leave there. This is a temporary fix that'll get you through until you can replace this cable run. So this is something that, you know, in real life, according to your exams and your certification exams and exams for me, it's going to be replace the cable run. But just a little FYI for you, in an emergency situation, you could get by with doing this little fix here, this little field fix, if you will. All right, next problem we might encounter is a connector open. This would be one of my ends is not terminated well, and this can happen. Bad crimps, bad terminations, that sort of thing can cause basically the whole outlet to look like it's not terminated. Relatively easy to do. So when I hook my continuity meter up to it, it's going to show fail, and when I go through fault check, it's going to show all 4 pairs are not terminated. All 4 pairs are open. As I hook it up to my wire mapping meter, it's going to try to say, hey, there's no cable here. Okay, the first time you encounter that kind of freaks you out, but when you see it again, go back, check all your connections, make sure everything's, you know, seated. Try your cable run again. If you still get this, now you have to check, you know, your patch panel termination, your outlet jack termination, and see which one is faulty. And for the connector open, again, if it's on the end like that, easy peasy, just re-terminate that end. Okay, and watch your punch down tool. What may have happened is you might have had the punch down tool backwards and you were cutting the wires off before it got terminated, something like that. All right, the next area we're going to get to is the wrong pinouts. I'm going to come back in the next podcast and start talking about the different types of wrong pinouts you could have in your cable terminations.